Hello. Hello. Uh, Hello everyone. It's my pleasure to present you this project about IoT agriculture. So this is our demo video. So this is how we can configure the Wi-Fi.
You can say a few words about your project background before you go on the demo, but what I mean with the demo is quicker. It doesn't mean that you can say a few words about the purpose of your project first.
So this project is inspired by Mr. Yan, and we link with the company, the Nene company, and the director is Mr. Motipai. And another company is Ancopac, is the hydroponic company. And this project is all about IoT agriculture to measure and control the humidity and temperature for a better product. And in the future, we may have if apply the foreign standard to export our product. So with this project, we can monitor the whole process without so that we can check all the parameters. So the foreign export can accept our standard. So this is our video demo. So this is how to connect the Wi-Fi to the PSP. We click to the configure Wi-Fi. We enter our SSID and password. We wait for the USB to connect. So the USB is already connected to the Wi-Fi. So this is our page. So we log in as user. So after we log in, we can use the feature page. So we click to the static to view the diary. So I will increase the speed. So as you can see, it's 2:13. The last time we collect the data, the humidity is 39 and temperature is 32. At this point, we config the temperature and humidity. The temperature has to below 35 degrees, and humidity has to above 55%. So if the requirement is not reached, the listing system has to activate auto. The humidity is still below 55, so the listing system has to run. And at this point, we set up the listing is turned on for 5 minutes. So after 5 minutes, the ESP has to restart and to gather the data again to see if it reached the requirement. Stop at around 20 seconds. The humidity is still below 55. this is how we see on our website. So the last one is the community is 62 already. So the missing system will start for 30 minutes after the next collecting data. Okay, it stops for 30 minutes. This, thank you for watching. So this is our directly camera from my house. So I will complete the system. So the listing only turn on for 20 minutes because the last time turn on for 5 minutes, the relay is broken because of the electricity. So the last one, the last is 29 and the limit, the temperature is 39. So we wait for 5 minutes and the misting system will start for 10 seconds. So this whole hydroponic system, as you can see, all the plants are sent by the water with nutrient. So we can save life and especially we don't have to use fertilizer to reduce the pest. Sorry, I want 1 minute to start the system. And the problem I saw yesterday is the relay because this system I've run for test for a week, but last night the relay is all broken. And luckily the ASB and the sensor isn't burned. So I have to replace the relay and set the whole system again. And if we want to continue this project, we have to change to the relay in the industry, the better relay and better ASB board and better sensor to maintain the work. It will work continuously. And because the misting time is only 20 seconds, so the result isn't change much. But when we set up it around 5 minutes, the result is changing from humidity from 30, it goes up to 69. So sorry for the delay. Yeah, so the misting system is spraying. And it's spray for around 20 minutes, 20 seconds, and it stop. And wait for the next 5 minutes to collect the data again. Okay, so we'll go to our presentation. So wait for the presentation so we can see on our website. This is our feature site. This is our diary. So we only display 10 data on this. So if you want to view all, you have to click on this button. And this is the chart for temperature and humidity. So this is the all data, the sensor. Okay, let's see the chart for the whole data. So we can create all process through this section. And all data will be sent to the library for user to share to each other via the forum. Sorry for the technical issue. Next, but we'll present our business.
I would like to introduce a little bit about my topic that we have chosen. This mainly talk about the how to apply the latest technology in a modern day to grow plants without using the old farming method. And as we know in Vietnam, the agriculture has always taken the lead, and it is regarded as the core industry in our economy. And this success on the in the agriculture often rely on the experience of the farmers that they accumulate over the generation. And the output is not only rely on the experience, but also is affected by many other factors like the weather condition or the insects. Therefore, in the era of the history, era of the industry 4.0, the farmers they can achieve more achievement by applying the modern technology nowadays. One of the most latest technology that I want to show you is the internet technology in agriculture, especially the high robotic system and hydroponic system is a system of growing crops without soil, and they often call the soilless farming. And the purpose of creating this system is because it is to track and store the information about the indicators to be able to publicize the process from sitting to the harvesting of land, and this way by this way the user can know their products is completely clean, and they know this don't use any fertilizers or chemical pesticides. And next, I will talk about the reason why I choose the hydroponic. And the first reason is because this system can save the space. And in the hydro system, the root don't need to spread because the water and the nutrition can deliver to them. And no, this the reason I talk the reason why I choose this system, and then I will talk detail. And the next reason why I choose is because the fewer chemical.
Sorry, I have a question. You said that you focus on this system, but you have only have two sensors, one sensor for humidity and one sensor for temperature. So how can you check this kind of nutrition? Yeah.
The CDS sensor we already test, but without board, the CDS can collect the data from the CDS sensor. So we have to abort this
But in the
data.
website there no information about it.
Yeah, because the CDS sensor cannot collect from these three boards. So if we want to use the CDS sensor, we have to move to another board. I have tried two boards, and the one cannot connect to the CDS sensor to collect the nutrient and the pH value in the water. So this is just our introduction. So we skip all the things and we go to the part that how it works and how we do in this project.
Okay, so I will introduce about why the IoT applied in the hydroponic. For reason is after the pandemic, there are things are more they are difficult, especially in terms of the agriculture export. Based on this system, which can later help the monitors, indicators affecting on the living environment as well as the process of production. This project will help the household who want to work on urban farming to achieve the higher efficiently, and also they can produce food. And for the other reason is the current regulation on the food safety is not applied for export. This solution can completely meet the needs of the buyer, and and this can help the hydroponic farms become productive in exporting their products according to the foreign food safety. And so I want to talk about how does it work. The main function is our system is to monitor and to control the parameters to help with the help of our sensors to produce the plant and vegetable at a faster rate. And the remote environment to eliminate dependency of the natural habitat. To ensure the year-round availability of all plants and vegetables is the main objective of this project. This project shows the hydroponic system which monitors and control the higher rate of the growth and also reduce the human dependency. As you can see, there's a sensor to collect the environmental system. If the parameter is not too strong environment, the irrigation system will automatically activate, and all data will be sent to a server. Also, so I want to talk about the website, and for this admin page, is the there's a login admin page which we would make the categories between the users and admin. And so when we got log into the admin page, it will be displayed as the home page, as the web page. It's front for the web page from the user. And so this is the device management for the admin. In this page, it has the same thing that in the user, the feature page in the user. However, in this front, we can edit and delete from the admin page. And this is the static page for the admin. As we can see, because there are several results as displayed in the website, so we just get only 10 data first, and then if we click in the view all data, it will be we can see the all results. And the later in the all results, we have been displayed the line chart about the temperature and humidity. And this is the website diagram that we want to introduce. And it has divided into the use case divided into two things. First thing is the users who register, login, and who register the information and then after that they register, it will check the validation and save into a database. For login, we need to log in to check the validation and when we finish, we will it's include from the user page. And for picture page, the connection is we need to log in to the account and then from picture there's the statistic link to the build own data page. The second thing is about the admin page. In the admin page, we have been divided into we log in and we can use fill the information, and after that we need to choose the admin category. So and so the difference is the user management of the admin page can include the link and add page. So for the next page, when we will
So we can see this is our use case. So on the left is our device box. It includes this board and a sensor which attached to the hydroponic garden and relay which attached to the misting system. So when the data is reach the requirement, so the relay turn on the misting system and the whole process in the data will serve to our cloud server, and the user can monitor and access to the controlling through our website. So how can the listing urination system work? So as mentioned before, the listing system is attached to the water tank. So the whole process is there's an electric water pump will pump the water to raise the length, and after that it will go back into the water tank. And when there's started on the relay on, the pump will activate the listing system, and the whole nutrient and the water is stored together in the water tank. So there are the methods to do this project. So we spend around 1 to 2 months to gathering science requirements. We have to change from soil moisture control to the hydroponic system. And I divide the group into two groups, the team into two groups. The Bình and Nam is the website group, and I will take care of the Arduino system. So Bình and Nam will design the website and the control code using Fusion 360 to design the 3D, and he will draw a 3D design of the hydroponic system and the device box. And after that, we have to program the website and database. I have to connect the Arduino to our database and website. And the hard thing is testing the whole system, because there are many errors and bugs of our system. So we have to test over again. And then after testing, we have to give the product to our client to get feedback. And after that, we have to bought the lens to test the last section, and we deploy our system. Okay, this is our roles team member. And all the reports we keep on Trello. We report every week from September to June. So thank you for listening of our presentation.
So thank you for the presentation. I have a question about if I have a new type of a sensor, how can I add it, plug it into your system?
Yeah. So this is our future section because we already have a member code. So each member has the unique code. So when the user buy a device, so admin will add the device into individual member. So that's the function we have to like do that later. But now we cannot do it. We only add the device for the whole every member. So we cannot separate individual members.
I mean, in Arduino you have different type of interface, right? So did you use the serial interface or just the USB?
I use the USB port to connect to the adapter.
The adapter.
Yeah.
And then on the adapter,
And so each sensor will connect to the board, and we can separate the board.
yes.
Yeah, if we can separate the sensor, but each member have to buy different board to have their own gadget. And according to that, we have to save update the board, not the sensor. It means our product is hydroponics and below is growing mushroom. So as your question, so we have two different sensors. One is collecting data from the plants, one for mushroom. So we have to separate it and
So that means you mean want that's the big box for the sensor. If you want to buy more box, you can add physically cable connection, and you declare all the damage.
yeah.
Okay.
So each user have to buy a box, and each box has 2 or 3 sensors. It depends on the board that you buy.
And I may want to know the previous cycle. I think he also planned for one group with a similar project that named Irrigation System for agriculture. And I know your reference about that group and what the difference and the news in the projects compared with the previous projects.
So the previous project is only deployed onto the local host, but our project is deployed to the server and install that can draw a draft, and it can automatically turn on the spraying system. And we have to like the function. So the main thing that this is the base because we don't have much time to finish the whole project as we thought. Because of the TDS sensor, I think TDS sensor is the biggest difference from the previous group. But now the board cannot connect to the TDS sensor, so I think the main thing is we can deploy it onto the internet and we can monitor through our own phone, and we have a camera to monitor through the gun.
So I just comment, not question on the project because the first time you cannot talk about the spot not clearly because you not many about the hydroponic, but the scope your of the project apply how many concepts, how many concepts, and the future will be open. You just talk this project will manage, measure and management the agriculture in the hydroponic. But I think in the hydroponic, many things you have to manage and control. Yeah.
Thank you.
So for an Arduino box, how many sensors you can handle at the same time?
I think now it's like 3 sensors can handle at the same time, but except for the TDS sensor, because the TDS sensor is used by the analog pin, the A0, and all the sensor from the temperature, everything is used for the D1 to 6, to 8. So this can handle around 5. I think I haven't test. I only test 2 sensors.
So because if you implement like a aerobic farm is very big, right? So you have to calculate how many aerobic set up in your farm and for every box how many sensors you can plug in box set it and so
Because this project is mostly about the urban family, so if just for the normal family to have it, and if we have a big farm, I will update into the another that is the can handle the and with higher data more, and I have researched that one can handle around 50 to 100 sensors, and only the family can use like around 5 or 10 sensors to gather the system up, get the data.
yeah, in your presentation you set up you have research about the TDS sensor, right? So in your design the system here, for example in the website design here, do you have any kind of design to like present this type of information on the website?
We had, but we already deleted because we have the table.
So how can we know about this? So are there any evidence you already implement the website with this kind of information of the TDS sensor, and now another way you cannot collect data, so we did it, something like this?
We had the code. So this code about the TDS sensor, and with this code, Arduino cannot receive the data. and which I changed from Windows D1 to the ESP 8266, and it the CDS sensor. I don't know why.
Yeah, but from the beginning, when you build the system and you design the database, you design the UI, you have to on time design to show this information. Not such stuff like this.
Because in the UI, like I talked to my client about the TDS sensor and it cannot work, and the client wants to delete the TDS sensor information on the website, and we don't have any UI design about the TDS sensor. We only add the array of the TDS sensor value. Our client wants to have this TDS data, but we have to change the port to test the sensor.
What kind of database you use for storing your memory?
We use PHP MacMe. Sorry. Database. What kind of database? What kind? This one. In the server, so I have to use the get post method. So kind of, I don't understand. We use MySQL storage for it.
Did you consider some time series database?
So let's now answer the page.
For database we take in the PHP, MyAdmin.
Right, my question is, did you consider some other database, like some time series database, reviews or something like that?
No, I just use PHP MyAdmin because it's a convenient and
I think if you use some time series database, it's more convenient and there is a lot of graphing tools and analysis tools you can use for that. Making those statistics is very simple.
So how many tables in your data?
40.
What are they?
This is admin.
Are they any diagram about this?
Yes. It's our database.
So what difference between admin and the member?
Admin is for the administrator who log in. That's our who create this website. And for the user, it's about
So why the admin table don't have like the last login category, something like this?
license in a member.
So you have member here, you also have the ID, username, and the password, and you have last login category confirmation. Why the admin table here don't have this kind of information like the member table?
Create admin account on the SQL.
So the other one you don't prepare account as well. Really?
So
sensors that you collect at different times. So, you know, temperature measurement could be more frequent than, like, for example, the water chemical EDS sensor measurement. You might not do them at the same time. You might have multiple different measurement points. But in the database, it's like you have one thing, it has a measurement of everything in the role.
Because we only have we test the two data, so we only create the table for this one.
And also, the system is not like to have multiple measurements. You said you have the EDS measurement as a kind of plan initiative, right? So you probably design a database and you can handle all kinds of measurements and multiple sources and different times. But now this dataset we have designed, there's one row with all the measurements for every sensor, and each time you get the measurement for every sensor exactly at the same time.
Yeah. So we get all the sensor at the same time.
Yeah, so that's not realistic.
My client wants to he wants to collect data at 3 times at the day, around 7 a.m. 7 a.m. Later at the night, they want to gather 3 data to get the diary log. So he wants to get all the data at the same time.
Okay. That's fine. It's a funny design, right? I thought.
Yeah, it's just a
Okay. I see. Cool. Right. My comment is to recommend the client to use some I2C sensor bus sensors, implemented so that you can plug in multiple sensors from the same Arduino board. You don't need to worry about whether it's a big family or a small family, and how many items they want to measure. Let them choose how many sensors they want to buy and plug in.
I'll check out and present to my client.
All right, I think it's time for lunch break.
Thank you for
Thank you
the
very
question.
much.